A batsman scores 100 runs in his last match and increases his average from 10 to 12. Find the runs he should have made if he wanted to increase the average to 13. So let us assume that initially he has played n matches and on an average he made 10 runs. So 10n is the total runs that he made in the first n matches. That is, we have the basic formula: average is equal to sum of all the numbers divided by number of numbers. So this is a basic formula. So sum of all the runs or sum of all the numbers will be number of numbers into their average. So initially n matches into their average 10. So 10n is the total runs that he made in the first n matches. And he made 100 runs in his last match. So in his next match, he has made 100 runs. So this is total runs that he has made. Divided by number of matches is now n plus 1. Initially n matches and then 100 in his last match. So total n plus 1 matches. And this average now has increased to 12. Earlier it was 10, now it has become 12. So let us just solve. I'll bring 10n to this side, so you will get 2n is equal to 100 minus 12, that is 88. So 2n is 88 or n is equal to 44. So initially he has played 44 matches, and in that last match n plus first match he made 100 runs. So total number of matches that he has played is n plus 1, that is 45. So altogether he has played 45 matches and his average is actually equal to 12. Now how much should he have made so that his average increases to 13? That is, 45 numbers are there. He wants to increase their average by 1. Instead of 12, now it should become 13. So how can the average of 45 numbers increase by 1? All the 45 numbers should be increased by 1, or any one number should be increased by 1 times 45, that is 45. So he should have scored 45 more. Then his average will increase by 1. Already he has scored 100 runs, he should have scored 45 more. So he should have scored 145. Then his average will increase to 13. So he should have scored 45 more than 100, he should have scored 145. Hence A is the right answer. A jar contains a mixture of two liquids A and B in the ratio 2:3. So you have a mixture which contains two liquids A and B in the ratio 2:3. So you can take it as 2x and 3x. This ratio will always be maintained. So you can form the equation as 2x plus 3x is equal to 5x. So if you take 5x of the mixture, it will contain 2x of A and 3x of B. For example, if you take 5 liters, it will contain 2 liters of A and 3 liters of B. Similarly, if you take out 20 liters, you have multiplied the total quantity by 4. So 2 into 4, 8, and here it will be 3 into 4, 12. So that 8 plus 12, 20 is taken out. Now the initial ratio of A is to B is 2x is to 3x. So if you consider the total quantity to be 5x, the ratio of A is to B will be 2x is to 3x. Now what they are saying is that out of this 20 liters were taken out. So if you take out 20 liters, that will contain 8 liters of A. So 8 liters of A has been removed and 12 liters of B has been removed. And 12 liters of B is poured into the jar. So to this 12 liters of B is poured out. Now the ratio is 2x minus 8 and quantity of B is 3x minus 12 plus 12. That is same as 3x, and this ratio is now 1:3. So let us just solve this ratio and calculate the value of x. Multiplying 2x minus 8 with 3, you will get it as 6x minus 24, that is equal to 3x. So x you will get it as 24 by 3, that is 8. So value of x is 8. Now what is the total quantity of liquid now contained in the jar. A is 2x minus 8, where x is equal to 8. So 2x is 16, 16 minus 8 is 8. So quantity of A is 8. Next, let us calculate the quantity of B, that is 3x. So where x is equal to 8, so 3x is 24. So total will be 8 plus 24, 32 liters. That is the total quantity of liquid now contained in the jar. That is option C, 32. A man can row at 5 kilometers per hour in still water. The speed of the river is 1 kilometers per hour. He travels upstream up to a certain point and then comes back. So let us form the equation for that. So first we'll find out the time required when he is traveling upstream. Time required is given as distance by speed gives you time. This is a basic formula. So assume that he travels a distance equal to d, and when he is going upstream, effective velocity is b minus r. So this is a time required for upstreaming, and then comes back. So when he comes back, the time required will be distance is same d divided by effective velocity b plus r. That is, initially he goes upstream, and when he comes back it will be downstreaming, and the time required will be distance by speed b plus r, and he takes 75 minutes for the full journey. So this is the time required for upstreaming, and this is the time required for downstreaming, and the total time is 75 minutes. Now we'll convert minutes into hours. To convert minutes into hours, you have to divide by 60. So that will be 75 by 60, that is 1.25 hours. That is, to convert minutes into hours, you have to divide by 60. For example, if you have 30 minutes, to convert minutes into hours, you have to divide by 60. So 30 by 60, that is equal to half an hour. For example, if you have 60 minutes, to convert minutes into hours, you have to divide by 60. So 60 by 60, that is equal to 1 hour. Similarly, 75 minutes is just divide by 60, you will get it as 1.25 hours. Now, a man can row at 5 kilometers per hour in still water. That is the value of B. That is the speed of the boat in still water. So, B is equal to 5 kilometers per hour. The speed of the river is 1 kilometer per hour. So, R is equal to 1. So, let us substitute both these values here. D by B minus R, that is 5 minus 1 is 4, plus D by B plus R, 5 plus 1 is 6, and that is equal to 1.25 hours. Now to solve this equation, I will multiply by the LCM of 4 and 6, that is 12. So all the denominators will go off. So multiplying by 12, 12 into D by 4, plus 12 into d by 6, that is equal to 12 into 1.25. Here 4 divides 3 times, 6 divides 2 times. So 3d plus 2d, that is 5d is equal to 12 into 1.25. So we'll just work it out here. So d, you will get it as 12 into 1.25 divided by 5. I'll just multiply both sides by 100. So this 1.25 will become a more manageable 125. So that will be 12 into 125 divided by 5 into 100. I have multiplied both sides by 100. Here 25 divides 5 times. Here 25 divides 4 times. So that will be 12 into 5, 60. By 5 into 4, 20. So 60 by 20 is equal to 3. That is the value of D. That is 3 kilometers. That is option A. A train moving at 36 kilometers per hour takes 12 seconds to pass a platform. So you have the railway platform like this, and you have the railway track like this. So you have the train here. The train is just about to enter the platform, and the train needs to completely cross this platform. Now to cross this platform, First, the length of the platform has to be moved. So we'll take the length of the platform to be P. So first the length of the platform has to be moved, then the train will be here, then after that its own body length has to be moved. So we will assume that the length of the train is T. So first the length of the platform, then the train will be here, and then its own body length T. So distance to be moved is P plus T. So distance by speed gives you time. The train is moving at 36 kilometers per hour. We'll convert it into meters per second. We'll multiply by 5 by 18. And that time is given as 12 seconds. Here 18 divides 36 two times, from which you will get P plus T is equal to 2 into 5, 10, 10 into 12, 120. So this is the first equation that we have. That is length of the platform plus length of the train. Total length is 120 meters. Let us solve the remaining part here. Also, it takes 6 seconds to cross a man running at 9 kilometers per hour in the opposite direction. Assume that the train is here. Train is moving in this direction. Now a man is moving in this direction. Now for the man to cross the train, the full length of the train has to be moved. So distance for the man to move is the full length of the train. That we have taken it as T. Divided by speed or relative velocity. They are moving in opposite directions. So relative velocity will be the sum of their speeds. That is, train speed is 36 and he is running at 9 kilometers per hour. So distance to be moved is the length of the train divided by speed or relative velocity. We'll convert it into meters per second. We'll multiply by 5 by 18. Time is given as 6 seconds. So we'll just solve it here. T by 36 plus 9, that is 45. So T by 45 into 5 by 18. And this is equal to 6. Here 9 divides 5 times, here 9 divides 2 times. So T, you will get it as 6 into 5 into 5 by 2. 2 divides 3 times, so 5 into 5, 25. 25 into 3 gives you 75. So T is equal to 75. So P plus 70, that is 75, is equal to 120. So P plus 75 is 120, or P you will get it as 45. So P is the length of the platform, that is 45 meters, that is option C. The price of petrol was increased by 10% and then reduced by 30%. By what percentage has the price reduced? Let us assume that the original price of petrol is rupees 100. Originally it was increased by 10%. So let us calculate the new value when it is increased by 10%. So new value will be, originally it was 100 into 110 by 100. So after increasing it by 10%, new value will be 110. And then it was reduced by 30%. So now the value is 110. It has been reduced by 30%, which means that the new price is only 70% of this value, because it was reduced by 30%. So now it is only 70% of this. So let us calculate the value. I will cancel out 1 0 here, 1 0 here also. So 11 into 7, it will be 77. So originally it was 100 and now it has become 77. So effectively there's a 23% reduction. So by what percent has the price reduced? It has reduced by 23%, option B.